Welcome to Part 2, the Building Tools, of the two-part series, Workflow 3, Geometry Creation Tools within Simergy. Just for a quick review, in Part 1, we walked through how to create the site context for a Libeskind-esque flashy neighbor. We used the freeform tool to create the base form and a typical shape to create the penthouse. We also showed how the project tree can be used to select different components and different features. In Part 2, we'll focus on how to create the building energy model geometry using one of the standard shapes as the base form and go through how the envelope can be manipulated in various ways. Then, to keep up with our flashy neighbor, we'll create a penthouse on the building to show how the shapes can be used to create more complex building forms. Let's get started. We'll continue using the model that we developed in Part 1 of this series, and we'll go to the Buildings tab. We'll reposition the view so that we can see both sides a little bit better. Now, similar to when we created the side objects, to create a building object, we'll start by selecting New. Now you'll see a default shape appear. We'll make this a 5-story structure, so we'll change number of floors to 5, base story being that it's starting at the ground level, so we'll keep it 1. We'll select, in this case, an L shape. Now you'll notice that when you select the L shape, you get a diagram down here representing that form so that you can see what the x1, x2 values and the shape parameters are. So it serves as a legend for providing information on that, and for the different shapes you'll get different diagrams. We'll keep the zone configuration the same. As you see, we're right up against the edge of the site, so we'll change the origin to account for the sidewalks. And you'll notice as I'm entering the values, it's updating the representation in both the 2D and the 3D view. We'll extend the back leg of the L a little bit more to go along that street side, and we'll make the shorter portion of the L a little bit wider. Now we can also make adjustments by changing things such as the floor-to-floor height, ceiling elevation, and other entries. We can also incorporate a plenum into this. You'll know if I select above ceiling, the diagram changes here of the section of the space and thermal zone, showing that a ceiling plenum is there, and then it's identifying that the height is how that entry is controlled. Another thing to note is that sometimes you'll see gray backgrounds on some of these fields, and what that means is that the values shown are being influenced by what you enter in other areas. But if I try and enter a direct number into that, I'm not able to. So for this case, we'll keep it as not having a plenum. Now let's preview. Now I'll zoom in a little bit on this building, and what you'll notice is that as a default, it's creating strip windows for each of the floors. So next we'll start adjusting the glazing representation to get something a little bit more interesting. One thing to also note is that there's a north arrow that appears on the 2D diagram. So if I want to end up changing the orientation of my building, I can do that by entering a different rotation in the origin here, and so that would allow me to adjust the building orientation overall. Now, jumping to the glazing tab, we're presented with a table that is going to allow us to adjust the glazing and add solar shading for the 4 facade orientations. One thing to also note is that you have different buttons up here to select different window arrays, and we can incorporate up to 3 window arrays per floor. An application of that is if you had a floor that had spandrel, vision, and daylight glazing, you could set up the 3 arrays that way. For this example, we'll do 1 window array. One thing to also note is that there are a number of capabilities and features incorporated in here, and it's worth taking some time to try things out and look at the support documentation for further explanation. Such things such as the template and glazing types allow you to associate those type of templates and libraries with the model, and which can ease the input process significantly. But getting back to creating our window array, Focus on the south facade first. We'll change the window to wall ratio to 40%, and you'll notice that the default when you're creating a model is set to 30% on all sides. We'll select a window width of 5, a gap of 2 feet. We'll select solar shading above, but we'll also make that continuous, and we'll make some adjustments on the east facade as well. In this case, we'll do a window width of 10 feet, and we'll keep that window gap of 2 feet the same. In this case, we'll put solar shading on the side. Now let's preview that and take a look at what it looks like. Now let's reposition the 3D view and zoom in a bit more to talk about a couple other aspects of this. As you'll notice, on the south side I do have continuous horizontal shading above the punched windows that I've created by selecting a window width in the gap. On the south side, on the east side, you'll notice that we have two faces because of the L shape. And what it has done is it's created the solar shades on both sides. Now, in reality, we would probably not want to have that incorporated on this back portion of the L, since the building is going to be self-shading itself. But for now, we'll keep it, and in later videos we'll show how you can adjust and edit surfaces to add or remove solar shades as well. So I'll keep the building name as building 1, and I'll hit save. And now the building is incorporated into the model, although I need to save it to make sure that it stays a part of the model. Now we'll quickly create a penthouse for this project as well. So once again, we'll select new. We'll keep the rectangular shape. We'll do one zone per floor because in a follow-up video we'll utilize this model to show how custom spaces can be set up. We'll keep no plenum. We need to change the orientation of this, the shape parameters, and the origin a bit so that we make sure that it sits on top of our building. As you recall, we created a 5-story building previously, so for a penthouse we're going to want to start at a base story of 6. We'll keep that at 1 floor. To match our flashy neighbor, we'll have a 15-foot penthouse. And now we'll adjust the origin, X at 30, Y at 40, X1 dimension to be 30, and Y to be 120. So it looks positioned fairly well. We'll keep all the same default glazing parameters and other entry points the same, and we'll preview that. We'll change the name to building Pent 1, select save, and now we've created both the geometry for our building energy model as well as for the solar obstructions on the adjacent site. You can also explore the project component tree to look what components have been added in a similar way that we did to the side objects in part 1 of the video. For example, by selecting space 2-2, it has made the second floor view the active view within the model in the 2D view and highlighted that space 2-2. And you also have other capabilities as we discussed previously as well. In this part 2 video, we created our BIM geometry using an L-shaped form as the base and a rectangular shape as the penthouse. We showed how the facade representation of the different orientations can be changed and how simple solar shades can be added to the model. Other Simergy videos go into greater depth on how templates and arrays can be leveraged to create more complex configurations. Hopefully the 2-part video series demonstrated how the site and building can be quickly and easily set up for your project if you're creating new geometry using the Simergy tools. Also, remember to check out the other 2 workflow videos that demonstrate the different options, importing an IFC file, and importing a DWG as an underlay to build geometry from. Until next time, have fun in the land of geometry.